On today's lessons, there's going to be a lot of times where you need to pause and do the work and then check back in. I am trusting that you will follow the directions and do what's best for your learning and make sure that you pause and check back in when you are ready to. So today we should be on lesson 5, exponents. This is the classwork page that you should have. I know it's pretty small, but I always figure if my 40-year-old eyes can see it, then you probably can see it as well. So for the opening exercise, it says, as you evaluate these expressions, pay attention to how you arrived at your answers. So evaluate means we need to solve. So please write next to evaluate, solve, which means find the answer. So they want you to find the answer of 4 plus 4 plus 4 plus 4, plus, etc., 9 plus 9 plus 9 plus 9 plus 9, etc., and think about how you found your answer. So when you are finished with finding an answer for that, log back in or push pause to find the answer to those, paying attention to how you got your answer, and then log back in or push play, push play to check if you were on the right path or not. If you are back with me, it means you have the answer to these items. All right, a couple of ways you could have solved this. Did you count on as you solved? Did you go 4, 8, 12, 16, 20, 24, 28, 32, 36, 40 to solve it? Or did you do 4 plus 4? Did you group them together? Or did you recognize that this is repeated addition and it's as simple as doing 10 groups of 4? Which is also 40. All ways that we could have solved these. Obviously, the most efficient one is the 10 groups of 4. 9, again, you could have counted on. You could have done 18 plus 9 more. You could have also looked that it is 5 groups of 9, which is equal to 45. And same thing here with the 10, 20, 30, 40, 50. On that one, it might just be as efficient to just count up by 10s because it's quick, or to recognize it's 5 groups of 10. Therefore, it is 50. Sorry. All right, now we're going to move into our exercises today. For examples 1 through 5, you are simply going to write them the shortcut method for repeated multiplication. How would you write that? Utilizing the exponent, and then also the opposite of that, or the inverse of that, which would, taking it from an exponent, what does this mean mathematically? Go ahead and do that for 1 through 5, pushing pause and then checking back in when you have that written. If you are back with me, it means that you have solved 1 through 5 and you are checking your answers. If you get it wrong, make sure that you fix it and write it correctly as I have. So for this one, I see that 5 is our main star here, so they're going to be our base. And then it is 1, 2, 3, 4, 5 times that they are on stage. That's a silly one because either way you wrote it, you would have got it right. But 5 to the 5th power is how we would say that. 2 is the main star on stage here, so they are our base number. They appear on stage 1, 2, 3, 4 times, so that would be 2 to the 4th power. 2 is the base, 4 is the exponent. When you see 8 to the 3rd power, that is a shortcut for repetitive multiplication, which means 8 times 8 times 8. This 3 directs that 8 how many times, we have to repeated multiplication, they get to go on stage. 10 to the 6th means 10 is the star. It goes on stage 6 times. I apologize. Again, we're going to try to use dots from here on out since we are in our algebra unit and x's could be confused as variables. G to the 3rd power simply means that we don't know what number it is, but whatever number it is multiplied together 3 times. So now it says go back to examples 1 through 4. Use a calculator to evaluate the expressions. You're welcome to use a handheld calculator or the calculator on your computers. And when it says evaluate, that means solve or find the value of those. So when you're doing 5 to the 5th power, you're going to plug into your calculator 5 times 5 times 5 times 5 times 5. Make sure that you go slow and steady and make sure that you don't make mistakes typing in or not putting in as many as you need to. So since you have the calculator, I might do it twice to make sure I got the same answer. Once you have your answers, check back in to make sure you are correct. If you are back with me, it means that you have your answers. So you know that 5 to the 5th power would be this. If you got it wrong, plug it back into your calculator and try it again. 2 to the 4th power would equal this. 8 to the 3rd power equals this. And 10 would be, and hopefully you remember that shortcut from 5th grade, that exponent really tells you how many zeros are included in that number. That was part of your work when you did exponents, just to get exposed to them in 5th grade. Obviously, we can't solve for g because we don't know what g is, and that's why it said examples 1 through 4. All right, this last question down here is kind of small, but this is one of the big takeaways from the last 2 lessons. What is the difference between 3g and g to the 3rd? Take some time to think about that and answer, and then check back in to see if you are correct. If you are listening right now, that means that you know the difference between 3g and g to the 3rd. So hopefully you said something along these lines. 3g means g plus g plus g, or 3 groups of g. It's repeated addition, which would, if g equaled 3, it could be 3 plus 3 plus 3, which is 9. G to the 3rd is a shortcut for g times g times g. It's repeated multiplication. Again, if g equaled 3, it would be 3 times 3 times 3, which equals 27. Obviously, multiplication gets bigger, much faster than addition, and they are definitely not the same thing because we come out with very different values when we evaluate them. Moving on to examples 6 through 8, we can also use exponents. Base numbers can be decimals or fractions as well. So for 6 through 8, you're going to either write out the long meaning of 3.8 to the 4th power, or take the shortcut of 2.1 times 2.1, and then use a calculator to solve them. So write them out the other version that you know how to write them, and use a calculator to solve them. Check back in when you have that completed. If you are back with me, it means you have written them in the alternate version, and you have found the value using a calculator. 3.18 to the 4th simply means 3.8 times 3.8 4 times. When you do that, you should have gotten 208.5136. If I have 2.1 times 2.1, I can see that's repeated multiplication. So the shortcut version of that notation would be 2.1 squared, or 2.1 to the 2nd power, which equals 4.41. Again, if you're getting any of these incorrect, change them on your paper and redo them on your calculator to see where your mistake was. When I have 0.75, 0.75, 0.75 repeatedly multiplied, I know a shortcut notation I can do is 0.75 cubed, or 0.75 to the 3rd power. So that would equal 0.421875. Whew. Next, we're going to practice using exponents with fractions. Hopefully, whoops, sorry about that. Hopefully you remember how to multiply fractions. Remember, multiplying fractions is easy peasy. It's simply, if you have 2/3 times 2/3, oh no, I don't want to do that one. That's part of your example down the bottom. Let's say 3/5 times 3/5. You simply multiply numerator times numerator and denominator times denominator. So that answer would be 9/25. So on 9 and 10, write them the alternate version, just like we did up here, and find their value. Evaluate them. When you're finished, check back in to see if you have it correct. If you're back, that means you have your answers. So you have 1/2 to the 3rd power, which would be equal to 1/8. 2 to 2/3 to the 2nd power means 2/3 times 2/3, which would be 4/9. So don't let the fact that there's fractions or decimals in the problem throw you. You know how to work with those. Now your job is to complete the back and think about those answers. When you are completely done with the back, you may go ahead and check back in to see if you have the correct answers or not. If you are back with me, I am trusting that you have done all the work and you are ready to check in to see if you are correct or not. So if you read the directions, you know that you could have used a calculator to find your standard form. For fraction base, you had to leave your answers as fractions. So these are vocabulary words you need to make sure you're aware of so that if you are asked to show exponential form, you know what that looks like. If you're asked to write it as a multiplication expression having repeated factors, you know what that looks like. And if you're asked for the standard form of a number, you know what that looks like. That's basically just the answer. So go ahead and look over these to make sure you have them correct. If you don't, make sure you're learning from your mistakes. Push pause if you need more time. For number 2, when it says 5 cubed, you hopefully remember that the exponent 3 represents a cube because there are no accidents in math. And if we have dimensions that are 5 by 5 by 5, length, width, and height, that would create a perfect cube. So the exponential form is here, written as a series of products. Remember, products means an answer to a multiplication problem. That would be 5 times 5 times 5, and then standard form is simply the answer. Same thing here. Hopefully you remember when you read 14 and, that's where the decimal goes. And you know 7/10 with the TH is one decimal place behind the decimal. And then squared means the exponent 2. Here's the exponential form, written as a series of products, and the standard form. Down here for this one, 2 cubed, or 2 to the 3rd power, if they said it was 6, what they probably did was multiply 2 times 3. How I would help them fix that is I would remind them that the purpose of exponents is to notate repeated multiplication. 2 times 3 is repeated addition. If I'm going to do repeated multiplication, I need to do 2 times 2 times 2, which would equal 2 times 2 is 4, times 2 is 8, not 6. After you have finished with these, your homework tonight is going to be both sides of this sheet here. So make sure you get that from your teacher and think carefully about those questions. And then if you have extra time, you may go to Prodigy Game, or you can go to gregtangmath.com and play Espresso.